Today we are going to discuss electric fields. You know that an electric field is a region of space in which an electric charge experiences a force. And so that field is actually generated by charged objects or an actual charge itself. So you also know from the definition or from the description that the direction of this field is the direction that a positive test charge over here will move if it was placed in that field. So let's test that out. So around every charge, you know, it reduces a field. So if I have this positive charge here, the direction it will move, because it is positive and like charges repel, the force that this charge will experience will be in this direction because it will push this one away. If I put this charge here, it will move that way because it will be pushed away. Similarly, if I put my positive test charge anywhere around this field, it will be pushed away according to the field diagram arrows, right? And this is how we actually get the field diagram for positive charge, is if by saying if I put a positive test charge anywhere in this field, it will be pushed away, and that is why the field diagram looks the way it does. Similarly, for our negative charge, if I put a positive test charge anywhere near this, remember there is a field, we can't see it. But if we want to map the field diagram, we know that if I put this below, it is going to be attracted because this is positive, this is negative, and opposite attract. There's going to be this direction of the field, pulling it towards the negative charge. If I put it above, it's going to be pulled downwards, right? And so if I put my positive test charge anywhere in the field generated by a negative charge, it is going to be pulled towards this charge, and that's how we get that field diagram. Now, if I want to figure out the strength of my electric field, I want to figure out what is the force that every charge is experiencing, right? What is the electrostatic force that the dividing line charge is experiencing? So this is the way of quantifying my electric field strength. In other words, it's very important to note that this field causes this force. Okay, this electric field generates this force, and this force is felt by this charge Q. So you can say that this formula as a whole is the experiencing formula, right? You want to know, if I was in a field, what force would I be experiencing? Experiential. So that is an experiential formula, right? And this, the unit is newtons per coulomb. In other words, for every coulomb, you're going to experience so many newtons. This is the other formula that we came across when we want to deal with electric field. But the difference between this and the other formula is that this charge causes the field. In the other formula, this charge was experiencing the electric field strength. Here, this charge is causing the field strength. So I'm using big Q and baby Q to differentiate between them. So in this, when you're using this formula, I want you to use the magnitude only. Okay, because the direction is very important, so we'll figure it out separately. And then the R is the distance from the point in the question. It's the distance squared from the point that they are asking about to the actual charge that is generating this field. So this charge generates this electric equation. This charge is experiencing the field. So that's the major difference.